Hello, chemistry friends. We are going to start with Unit 0, Chemistry Skills. This is our first topic on elements and ions. You can use your guided notes to follow along. We will identify during this video elements and ions and write their formulas from their names. All right, let's start with the names of the elements. This is something we're pretty familiar with from our previous chemistry class, but we need to be able to recognize and name the following elements from their symbols. So we're going to do a little practice. Take a minute, pause the video, and on your guided note sheet, try and write out the name of the chemical symbol that's given to you. Try not to use any references, and when you're ready, we'll come back and check them. All right, so hopefully you have gone through as many as you can, so let's check and see what we got. So this is going to jump around a little bit. We start with Na, that is the symbol for sodium. Next, we've got H, that's our symbol for hydrogen. We've got B for boron. We've got K for potassium. We've got He for helium. We have P for phosphorus. We have F for fluorine. We have N for nitrogen, Ca for calcium, Li for lithium, C for carbon, Ne for neon, O for oxygen, Mg for magnesium, Cl for chlorine, and S for sulfur. So check yours, see how many you got. Hopefully you did pretty good on that. This is some practice because we want to be able to recognize these and use these symbols and elements throughout the year. So it's good practice to get our brains going and recognizing these symbols again. Now let's talk about charges on ions, and we're going to focus on the main group elements. So the charges of the main group elements, which are groups 1, 2, so the first two columns on the left side of your periodic table, and then groups 13, 15, 16, 17, so most of the right side of our periodic table. Those are based on their number of valence electrons. That's how we get our charges for these elements. So group 1 and 2 elements, so the first group starting with hydrogen, group 2, and next to it group 2, have 1 or 2 valence electrons, the electrons on the outside energy level. To become an ion, they easily lose their valence electrons and get a charge of +1 or +2. And we can write it +1 or 1 plus. When it's a 1, you do not have to write the actual 1. So all of group 1 elements get a charge of 1 plus, and all group 2 elements get a charge of 2 plus. If we jump across the periodic table, skipping the transition metals to group 13, where it starts with boron, it has 3 valence electrons, and so it loses those and gets a charge of 3 plus. So when it loses its valence electrons, it has more protons than valence electrons, giving it a positive charge. Next, group 15. So we skip group 14 because it's the one that starts with carbon. It doesn't really have much of a pattern that occurs there, so we're going to skip that one. Group 15 has 5 valence electrons, and they can, instead of losing those, it's going to easily gain 3 more to get to 8. It wants to achieve that octet of 8 valence electrons. So they gain 3 electrons and get a charge of 3 minus. So that's nitrogen's group. Group 16 elements are similar. They have 6 valence electrons, so they can easily gain 2 more to get a charge of 2 minus. So the number of electrons they're gaining gives them their charge. And group 17 elements have 7 valence electrons, so they can easily gain 1 more to get a charge of 1 minus. So this is very familiar from last year. This is something that we went through and talked about then and labeled our periodic tables. So this is a way of predicting our charges on those groups. All right, so you can see the periodic table on your paper there. And we can see that group 1 here with hydrogen has a charge of +1. Group 2 with beryllium has a charge of +2, so they have 1 valence electron for that group, 2 valence electrons, so it's going down the column. We skip our transition metals for now, we'll talk about those next. We jump over, this is group 13, so it has 3 valence electrons, it loses them, it gets a 3+ charge. We've got carbon's group that we skip. Nitrogen's group, that is group 15, gains 3 electrons to get to 8. Group 16 gains 2 electrons to get to 8, so 2- charge, and group 17 gains 1 electron to get to 8. Remember, group 18, they already have a full octet, so neon, argon, krypton, from there down they have their 8 valence electrons. The only element that doesn't get an octet really is helium in that group because it only has 2 valence electrons and its orbital is full with 2. All right. All right, so transition metal ions, that center group in the periodic table. Transition metal ions do not follow a pattern. Therefore, their charges must be found from a chemical formula given, and we'll review this when we go over chemical bonding, or they're given in the name of the chemical using a Roman numeral. So we'll do a quick review on that right now. So we've got iron 3. So iron is our transition metal. Its symbol is Fe, and it has a Roman numeral 3. So that's going to tell us it has a 3+ charge. Our next one has lead, and its symbol is Pb, and it has a Roman numeral Iv. V represents 5. So 1 before 5, IV, put it up here, is 4. It's the number 1 before 5. If you have VI, it's 1 after 5, so it's 6. Okay, so lead is going to be a 4+ charge. And then our last one, manganese, is Mn, and it has a Roman numeral 2, so it would have a 2+ charge. So that's how we would find the charges for those. The other elements, oxide, sulfide, nitride, we'd find their charges just how we looked at on the previous slide by looking at their group on the periodic table. It would tell us what their charge is. And then from there we could go back to our crisscross rule and write their formulas, which we'll practice later on. But this is just a way to get their charges. So we can find charges for our main group elements from the periodic table and from our transition metals from their name. All right, polyatomic ions, so another group of ions. So polyatomic are a group of atoms that is covalently bonded, so they're sharing electrons with each other, but as a group has either gained or lost electrons to stabilize the compound. These ions can have, can then form ionic compounds with other oppositely charged ions. So we have something that is sharing electrons, that's covalent bonding, and then it forms an ion, and then it can form ionic compounds with other oppositely charged ions. So it does both types of bonding within the same chemical. So we're going to take a look at just some examples of polyatomic ions. So some of these might be familiar from last year. Nitrate, and its symbol is NO3. So it says we have 1 nitrogen, we have 3 oxygens, and that whole thing together has a -1 charge. So that means it's gained 1 extra electron. So if nitrogen brings 5 valence electrons and each oxygen brings 6 valence electrons, we could add all that up, but then we get an extra 1 because of that charge there. So that's nitrate symbol. Sulfate is SO4, so a sulfur and 4 oxygens, and it has a 2- charge. That means that 2 electrons have been added to that formula, to that chemical. All right, so to give you a visual, this one might be a sulfur and it's covalently bonded, so it's sharing electrons with its oxygens. They would have their octet of electrons for each one, and to form all of their octets, it would have to gain 2 electrons. Okay, so that's sulfate. Continuing, we have carbonate. Carbonate's formula is CO3, so carbon and 3 oxygens, and it's also a 2- charge. So you'll notice we're not really seeing a pattern with these formulas. So the ATE ending indicates that it has more oxygens or one more oxygen than the ITE. So we could make nitrite, change it to ITE, and it would have one less oxygen, but the same charge. You could do the same thing with sulfate, make sulfite or carbonite, and you just drop an oxygen. So that's something else that can occur. Hydroxide, that's a different one. It has a different ending there, but it's got hydrogen and oxygen, as you can tell from the name there, and it has a negative charge there. Another one, fifth one, is ammonium. Now this one again has a little bit different ending. This one is special. It's nitrogen, 4 hydrogens, and the whole thing has a positive charge, so it lost 1 electron. This is our only positive polyatomic ion, okay? The only positive one we're going to have. So these are some of our polyatomic ions. You've got a complete list on your paper, so those are going to need to be memorized for our class. All right, lastly, I just want to remind you to be careful with your vocabulary, all right, as we use terms. We can't just call everything in chemistry an element or an atom or a molecule. These words have meaning, and we need to use them in the correct context and use them to describe the correct thing. So an atom is a basic unit of a chemical element, okay? We can say any element on the periodic table, we can say we have an atom of it, and that is just one single particle. Okay, that has that identity, that element. An element is one of the 118 substances that cannot be broken down into simpler substances and are the primary constituents of matter. So they are what matter is made of, elements. Each is different by an atomic number, or by its atomic number, which is the number of protons in the nucleus. So we can tell if it's an atom of hydrogen versus an atom of helium based on our number of protons. They are both atoms, but they're atoms of different elements, right? Different identities. Then we have the term ion. An ion is an atom with a net charge, either positive or negative, due to the gain or loss or gain of electrons. So if it's positive, it lost. If it's negative, it gained electrons. Okay? Positive is a loss of electrons. Negative is a gain of electrons. Because you're gaining a negative thing, you become more negative. If you lose the negative, you become more positive. And last, we have polyatomic ions, which is a group of atoms chemically bonded with a net charge of positive or negative due to the loss or gain of electrons. So like we saw in the last slide, it's a group of atoms that have that charge together. All right? That's it for today, and I will see you in the next one. Thanks.